Okay. I have it in the home, so okay, there it is working that. Maybe some problem with it. Okay, good afternoon students. Let's carry on. Import, import downloads 12 JPPT electric charges, importing file, then we had done till which point? How we were doing this, right? We were doing the electric field. How does it look like? So we had done this part also. Plot of electric field due to negative charge, this plot of electric field due to positive charge, plot of electric field due to negative charge. So plot of electric field due to negative charge. Okay. Hmm. So plot of electric field due to negative charge. So let's do that. How will the plot look like? Let's see. So what will be the electric field at this point? At this point. So what is the electric field formula? You see E is equal to what? KQ by R square, right? And since R is tending to 0, E is tending to infinity, right? So electric field magnitude is going to infinity as we are very close. This point is very close, right? So R is tending to 0. So electric field is tending to infinity. Got it? So I want to find out how the electric field will look like and it will be in which direction. So it's a negative charge, right? So because of negative charge, the electric field is towards, right? So electric field will be in this direction. Got it? Towards the negative charge. So the component will be positive or negative. Electric field is in this direction, right? So component will be what, guys? Positive or negative? It's a left direction, means it will be negative, right? Component is negative. And if electric field component is negative, and that to what? A high negative, tending to infinity. So it is a high negative value, means it will start from here, right? So it will start from the bottom and it will tend to 0. As you go ahead, it will become 0. Why? Because at infinity it is 0 anyway, right? Similarly, if you talk about this point here, electric field will be towards it, like in this direction, right? And it will be having positive or negative component. It will having positive component, right? And again, it is very close. So electric field will go to infinity, right? But infinite and positive, right? So it will start from here, and it will become eventually 0. So this is how the graph will look like due to a negative charge. The electric field, if you plot, this is the plot of what versus what? X versus Ex. Okay, right. let's go ahead. Due to negative charge. We already seen negative charge, right? Two positive charge. Let's do this one. So if you have two positive charge, so what will be the electric field? Let's see. Here it will be, let's say Q, and here also it will be Q. Right, so both are Q and Q. Now let us find out the electric field due to the positive charges. So at the mid this point, what will happen? Both the electric field will come from here because they'll go away like this and like this. So what will be the electric field at the center? For sure, electric field will be zero, right? So here it will be zero at the midpoint. It will be zero, right? And just on this side, it will be because of the positive charge. It will be in this direction. So it will be positive and highly positive. Highly positive means it will start from here, correct? Because very close means high magnitude, right? And also it will be away from the here from this charge. It will be away, right? Away means it will be positive component, right? So positive it will go, and then it has to become zero. So remember this part. Got it? Similarly, at this point, electric field will be in the left direction, away from it, right? So its component will be negative. It will be high but negative, right? So the graph will start from here, and it will touch this, and it will touch this, right? I make sure it starts from minus infinity. So see, again I'll tell you, it's negative, right? High negative. High negative means it has to start from the bottom because very close, so it will be high value, right? Why it will be high? Because you know the formula is what? KQ by R2, right? So R will be less, electric field will be high. So it will be in this direction, and in the left direction means negative, so negative high, right? So it will be something like this, and then it has to become zero, and then it will go like this. Now see, here field will be, because of positive charge, it will be in this direction. That means positive component and very positive high, right? So it will start from here and it will become all the way as you go, it will become zero. And next, at this point, electric field will, because of positive, will be in the left direction, right? That means negative and negatively high. So it will start from here and go to zero. So this is how the graph will look like for two positive charges. Got it? Take this down. next for two negative charges. So let us say this is minus q, right? So at this point electric field will be towards it, right? Towards it means it will be negative, right? So it will start from negative and negative infinity, right? And here is another charge which is, let's say, which is again negative, right? Minus q. So at this point electric field will be where? Negative means it will be towards, right? So component will be positive. Here component is negative, here component is positive, right? Positive means it will start from this point, from the top, right? And what will be electric field at the center? Like here, what will be the electric field? Electric field will be zero because both of them will pull in this opposite direction, right? So it will make electric field zero at the center. And it will make positive in the top direction, right? So it will start from here and it will go to minus infinity, like this. So this is how the graph will look like on this side. Now let's talk about this side. Here it will be towards minus q, right? That means positive component. Means it will go from positive to all the way to 0. Right? Whereas here, because of the negative charge, it will be towards the left, right? Which means it will be positive and negative. Left means negative. So it will start from negative and go all the way to 0. Why go to 0? Because at infinity electric field will be 0. Right? So take it down. Let's go ahead. Let's do this question. If two charges are kept minus 4q and q at minus a comma 0 and a comma 0, the graph showing the variation of electric field, it should be, along x-axis is what? So let us start with the first one. They're saying minus 4q and minus a comma 0, right? So here you have got a charge of minus 4q. At this point, electric field will be towards. So component will be negative, but it is showing component positive. That there it is wrong. Right? Now here the electric field is becoming zero. Electric field can't become zero here. It has to go infinity. This is also wrong. Here, okay, let's first see the here. So here the electric field is zero, is becoming minimum at this point. But in between the graph cannot be symmetric, right? This graph is symmetric because this white can't be symmetric because you have minus 4q minus 4q and q, right? And this is a symmetric graph, right? So you can't have a symmetric graph. Minus 4q and q is there. There has to be non-symmetry, right? So this makes more sense. There is non-symmetry, and then here you have minus 4q, and here you have q, right? And because of minus 4q, the electric field will be towards it, so positive. That's why it's going to positive, right? At this in this direction, electric field will be in this direction because it is a negative charge, right? So the component will be negative. So it is going from negative. Okay. Now have a look at the other charge. This one. Here it is q. So at this point it will be away. Away means negative. That's why it's starting from negative, right? At this point, electric field will be again away, which makes it positive. That's why the graph is starting from positive. Got it? The third option is correct in all respects. Take it down. Now let's go ahead. Let's do this charge, this question. A metallic ring is uniformly charged with charge Q. A small element of angular weight d theta is cut out. The electric field at the center O due to this residual charge ring will be how much? So basically, you know the electric field due to this entire ring at the center will be 0. Now what I am doing is I am taking out this small part from the ring and I am writing down the electric field due to the remaining part. Right? And you have to find out what will be the electric field due to the remaining part. So let us see how to do this. How to find out electric field due to the remaining part. So full ring charge is Q, right? Now if you see, this entire is a ring, right? And the charge is total, what is the charge? Q, right? And you remove a small portion of it. So let me draw a bigger diagram here. There it will be difficult to explain. So let me draw a bigger diagram in this place. Here it is. Oh, nice. Okay, fine. So I have drawn a circle of radius r, which in the center is also shown. So what I'm going to do is I'm going to cut a small portion of out of it. Right, and let me draw two lines for that. Right. So the entire ring has got positive charge, right? But this portion, if you see, has got no charge. This portion, has got no charge, right? So no charge is equal to what? No charge means positive also will be there and negative also will be there, right? So if positive and negative both the charges are there, that means there is no charge. That's what it means to be no, to have no charge, right? Positive also there and negative also there. That means it has got no charge. So exactly that is what is happening here also. The rest of the plate is positive anyway, right? There is no doubt with the rest of the plate. The rest of the plate is positive. But this remaining portion has got how much charge? Plus and minus both. So it has plus also and it has minus also. Both charges are there. So together plus and minus becomes how much? Together plus and minus becomes 0. And that is what the question is. Which is saying that net charge is 0, right? It has got no charge. So I want to find out electric field at the center due to this entire combination, right? And how can I do that? So electric field at O, it is electric field at O due to positive and electric field at O due to negative. Right, because of both of them. And you have to find out the electric field at the center due to the residual charge. Right, so electric field at center we have to find out. Due to this system means there is only which charge? Positive charge at this point, right? But positive charge is there and there is no charge here. So no charge can be represented by what? Positive also and negative also, both. So with that, let us find out electric field at O. So electric field at O will be electric field at O due to all the positive charges plus electric field at O due to all the negative charges. Right. But what is the electric field at O due to all the positive charges? This answer will come out to be how much? 0. Because all the positive charges will send electric field against each other, making it 0. So electric field at O will only be due to which charge? Due to the negative charge. So let this negative value be minus q. So what will be the electric field here? Or minus dq, because it's a small charge, right? So what will be the electric field at the center due to the negative charge? Because this is due to the positive charge, the electric field is 0. So the net electric field will be only because of the negative charge. And what is the value of that? That is k dq by r square. And dq is how much? I think you have given a, yeah. So let's write dq. How can we write dq? D theta is given. So see, q charge is there on how much angle? So Q charge is there on how much angle? Full angle is 2 pi. So that means you have Q charge over 2 pi. So and dq charge over d theta, right? So what we can say is charge per unit angle is what? Is dq by d theta, which can also be written as q divided by 2 pi. So from here, what is dq coming out to be? Q divided by 2 pi into d theta. So that is dq. And that value of dq we can take and substitute it here. Which is q into d theta divided by 2 pi. And divided by r square. And since it's a negative charge, electric field will be towards it in the upper direction, right? So that's what you have to find out. You have to find out the electric field. N is the term. So what will be the value of N? It will be in the upper direction. Upper direction means N will be positive J cap. So it will be the second option. Okay, but it could be both, right? This and this. We have to find out which one it is. So let's continue to do it. So I put the value of dq here. It comes out to be this, right? That's the value of dq I substituted. And now, if you simplify this, what will you get? That will be k q d theta divided by pi r square into 1 by 2. That is the electric field का magnitude. And what is the direction? In the upward direction. That means direction is j cap. And now if you see this, k q d theta divided by pi r square. K q d theta divided by pi r square. And what is the rest over thing is j by 2. So which option it is? J by 2. Right? Take this one. So let's go ahead. Let's do this question. This is asked in JEE Mains 2019. Three charges Q, Q and Q are placed at respectively at uh, 0 d by 2 and d from the origin on the x-axis, right? At 0, at d by 2 and at d, right? Call them Q naught. So the side charges are all Q naught and the center charge is Q. If the net force experienced by plus Q placed at x equal to 0 is 0. So here at x equal to 0, the net force is 0. Then what is the value of Q? You have to find the value of Q. Right? And on this, the net force is 0. F net is 0. Right? So you have to find out what will be the value of Q. Q value you have to find out how much should it be so that net force is 0. Right? So think about it. In the meanwhile, I'll upload the notes. Then I'll also get back to see this question. So what we did today, EX versus X graph we did. What else we did? Problems on Coulomb law. What else we did? Other than that, that's it. Okay, so let us do that question now. How to do this question? What is the value of Q? So See, you want net force to be 0 on this object, no? So let's write down the forces. It's that simple. So if it is Q, no, the force due to this, we want the net electric field to be 0 here, right? Net force to be 0. So this positive charge, this Q will send the electric field in this direction, right? And okay, let's first start with this one. Let's start with this Q naught. Q naught will send a charge in this direction, for electric field in this direction, away. And be how much? K Q naught by distance square, right? Where this is the distance d. And similarly, this charge has to send electric field in this direction to cancel it, and it will be how much? Kq by distance square, d by 2 also, right? And both need to cancel each other. Means cancel means this and this should cancel each other. So you have kq naught by d square must be equal to kq by d square by 4. Right? So q comes out to be how much? Q naught by 4. Right? And that too, it should be negative. That is why electric field is towards it, right? For it to be towards, it has to be negative charge. That's why the electric field is towards it, right? Whereas because of Q naught, it is away. So this will be negative of Q naught by 4. So which option we are getting? Got it?